It seems that everyone is talking about Wordle these days. It's flooding my Twitter feed, and the searches are at an all-time high on Google Trends. If you still haven't hopped on the Wordle bandwagon, the goal is to guess a 5-letter word using no more than 6 tries. After each guess, the letters that you guessed right in the correct position are shown in green, and the correct letters in the wrong position are shown in yellow. Here, in this grid, I can type my first guess of risen. And this shows me that R, I, S, and E all appear in the word, but they're all in the wrong location. On the next guess, I get 2 letters in the correct spot and 2 more in the wrong spot. We also know that neither N or A are in the secret word because they're highlighted in gray. I'll stop here since I'll have my computer program do the rest of the work once I finish writing it. On the Wordle subreddit, I found links to all possible answers to Wordle. These are mostly simple words, and there are about 2,000 of them. Also, there's a list of words that can't be answers but are valid guesses, which we can use to get more information about the secret word. There are about 10,000 of these for a total of 12,000 valid words that we can type into the website. The goal is to make an algorithm that is fast, so it takes no more than a few seconds to guess the secret word, and an algorithm that is accurate, so it will always guess the word using 6 tries or less. So the big idea here is we have the guess list, right? We have words G1 through GN, and this guess list is about 12,000 words as we just saw from the Reddit thread. And then we also have the possible answer list, which is about 2,000 words. And then the goal is to make guesses from the guess list such that we narrow down this possible answer list more and more. And once we narrow it down so that one word remains, we know that we have our answer, and it's that one remaining word. So more technically, how we're going to do this is we're going to have this matrix in our code. So for now, let's pretend that the guess list and the answer list are the same, and I'm denoting them using W1, W2, etc. So the numbers in this matrix are the number of possible answers that we narrow down our answer list to after making a specific guess. So when we guess W1 and the real answer is W1, well, we just guessed the word, so we narrowed down the answer list to just 1. We got extremely lucky. And when we guess W2 and the real answer is W2, we also narrow it down to 1, and same thing for W3. We're just guessing the word correctly. However, when we're not so lucky, we can get a different number. So when we guess W1, but the real answer is W2, maybe the information that we get from that guess allows us to narrow down our answer list to 3 words. And then when we guess W1 but the real answer is W3, maybe we narrow it down to 6 words, and so on for all of these numbers. So we're going to build this matrix in our code using the information that we can get from the guess list, answer list, and the feedback from the actual program. So how do we choose which guess to make given these numbers? Well, one choice is to take the average of each column and choose the column with the lowest average. So we would basically choose the column that on average narrows down our answer list more. But the technique I chose to use is to minimize the worst case. So when we guess W1, it will narrow down our answer list to 6 or fewer, right? We can narrow down to 3, we can narrow down to 1, but we're guaranteed that the number of words in the answer list will be no more than 6. For W2, this number is 8, and for W3, this number is 7. Remember, this is a fake example, but this is basically what we're doing in the code. So now, how do we choose the right guess? Well, we're going to choose word 1, and that's because word 1 guarantees that our answer list will be no more than 6 words in length, while W2 and W3 have worse guarantees, right? This one guarantees it will be 8 or less, this one guarantees it will be 7 or less. So we're going to choose W1 as our guess here, and then we will do the same procedure for every guess that we make, but we will of course absorb any new information that we get from making that guess. So we will absorb whether the letter is green, whether it's yellow, and that will help shrink down our answer list. So more generally, we're going to have guesses here, G1 through GN, and then answers from the answer list, A1 through AM, and then we're going to build up this matrix. And once we build up the matrix, we'll look through it, and then we'll find the column that has the best worst case. And then the guess that corresponds to this column, that will be the guess that we make. So this is the code that I came up with. I won't go line by line, but I will explain the gist. So at the top, we actually have two functions that we wrote that allow us to retrieve the full list of possible Wordle guesses and Wordle answers that we got from the subreddit. Then in the main function, we actually call those functions, and the narrowed down list starts as all answers, but we narrow down throughout the code. We also generate a random answer, which allows us to evaluate our guesses with the true answer. This is like the secret answer that the code doesn't really have access to, except through the evaluate function that you'll see later. And then we make 5 guesses. We run this loop 5 times. Why 5 and not 6? Well, that's because at the very end we have a check which says if there's only one word left in our narrowed down list after those 5 guesses, we make that as our 6th guess. So there are actually 6 guesses, but the loop only runs 5 times. So I'll just comment that this is basically our 6th guess, or the n plus first guess. Afterwards, we have this min word count variable, which is the value we're trying to minimize. I set it to something large like 1,000,000, but this is essentially the length of the narrowed down word list, or the narrowed down answer list. Then here, if the guess number isn't 0, we consider all words, but if it's the first guess, then we just guess the word arise. I tested this, and this is the best first guessing word for this algorithm, but you can also go to this link right here, and it will show you some other really good starting Wordle guess words, and arise is actually on that list as well. So later on, we look through every word that we're considering, and then every possible answer in our narrowed down list, and then we evaluate them with each other. The evaluation function is pretty simple. It's just 0 if the color would have been gray, 1 if it would have been yellow, and 2 if it would have been green. So it does the same thing as the colors that you see on the actual Wordle website. And once we do that evaluation, then we save our results. So the key to this Python dictionary is the evaluation, a tuple of the evaluation, and then the value is just a list of all words that have that evaluation, list of all possible answers that have that evaluation. And here's the main line. It basically finds the worst case, right? It looks at the max, so the worst case length of the narrowed down list after making a specific guess. And if we see that that worst case is better than our current saved worst case, which is set to 1,000,000 at the beginning, then we update that min word count variable and update the chosen word. So this is how we're searching every column in that matrix that I just showed you in the slides and finding the best guess, which has the best worst case. And then this line right here narrows down our answer list using the evaluation that we get, using that answer that we randomly generated, and then the chosen word that we chose by looking through this matrix. And that's about it regarding the algorithm. Basically, this function returns true if we guess the word and false if we do not. These last 2 functions allow us to test our algorithm. So the getTime function shows us that some of the slower Wordle solution attempts take 5.5 seconds, but the average is 2 seconds per Wordle puzzle, which is fairly fast and meets the goal that I set out in the slides. And then the getStats function gives us the percentage of the puzzles that we're able to solve. And when we run it on 100 puzzles, it's actually able to solve all of them using 6 guesses or fewer, which definitely meets our goal and shows that our program is nearly flawless. As you know, Wordle only lets you play once a day, so we will also use this other website called Wordmaster to try out our algorithm, and this website lets us play as many times as we want. This site has a slightly different word list, but that's an easy fix to make in our code. I won't go over the code too much, but we essentially use Selenium to be able to read each website's feedback on our guesses, and we use the keyboard library to type in our guesses. Let's give it a try on the official Wordle website. We call run program in the terminal, and once we press escape, the program starts. So I'll press escape right now, and there you go, it made its first guess, arise. Then it makes another guess, abhor. And there you go, it took just 3 tries and it guessed the word of the day, Shire. That's pretty good. Now let's run it multiple times on the other Wordmaster website. So I'm going to go here in our code and then change the boolean up here to false, and this just runs a different set of instructions to open a different website and read its content. But this website is very similar, so here I'll press escape and it will run multiple times. There you go. As you can see, the program gets 10 in a row. There's something else I want to try. There's an ongoing BotFights competition where we can submit a Wordle bot and compete with other bots. The leaderboard shows how many attempts it took these bots to solve 1,000 Wordle puzzles. The leaders average just over 4 attempts per puzzle. Let's figure out how to participate. So basically we need to adjust this play function to run our code given a string input from the competition. This will take some modification. Alright, I made changes to the matches and play functions. The challenge here is that their answer list has all 13,000 words, not just the 2,000 that we had. So it might take more tries than we anticipate, and it will cause our code to run for a longer amount of time. I ran a test and got an average of 5.9 guesses per word. It's not too bad, but it's worse than I expected because we were averaging just over 4 when we were running it before. Apparently I did have a bug in the matches function, and also I was using the narrowed down list to choose guesses from. The full list of 13,000, however, is too big for us to be able to search through, so we will choose 1,000 random words and then choose the best guess among those 1,000. This allows our program to still be accurate, but it also doesn't take too long to run. And with that fix, we average 4.6 guesses per word, which isn't too bad, and I'm ready to submit this bot to the leaderboard. And here we are in 9th place in the leaderboard with 4.6 guesses per puzzle on average. We were very close to the competitors above us and could potentially beat some of them if I gave my program more than 1,000 guesses to choose from. Still, I'm very happy with the result.
Several days later.
Actually, I wasn't that happy with the results. I'm about to post this video in 2 hours, but I wanted to film this little update. So instead of just running it on 1,000 random words, I decided to run the full thing, even though it was going to take forever. And also I'm using the average method. So before we were trying to find the best worst case, but now we're trying to find the lowest average number of answers in the narrowed down list. So you can look at this code later, but this actually ends up performing better. Running the whole thing took 2.5 hours because we're looking through all 13,000 words per guess, but now we're number 6 and actually very close to the number 4 and the number 5 person. So huge improvement right here. If you're new to the channel, I encourage you to subscribe because I post many videos like this one where I try to use code to beat various games. Thanks for watching.